Alrighty, in this video, we are doing a continuation of what we did earlier with inverse trig and compositions of trig functions here. For problems 10 through 13 here, what's going to happen is they're not unit circle values, and what we need to do is make our little right triangle based off of what we know so far. So in this example here on number 10, we have sine of inverse cosine of -3/5. The first thing that I'm going to do is think about where inverse cosine is. So in this case, inverse cosine is either in quadrant 1 or 2. And then I'm also going to think about when cosine is negative, because that's what we also want, because this is negative right here. So cosine is negative. If I were to do my little thing right here, in quadrants 2 and 3. So in this case, we know that our triangle needs to be made in quadrant 2. Now, the reason why it's important for us to do that is because I don't know where this negative is, because it could be -3 or it could be -5. But that's why I'm making this triangle. This is going to tell me that the base here is going to be negative. All right, I'm going to make my theta right here. And for cosine, it's going to be adjacent over hypotenuse. So we have adjacent, and then we have my hypotenuse. Now, this is a 3, 4, 5 triangle, so go ahead and figure out that, hey, your height's 4. So now we could say that for sine of inverse cosine of -3/5, sine is going to be opposite over hypotenuse. So this right here becomes 4/5. All right. If I were to do 12 here with sine of inverse tangent of -24/7, once again, we want to think about the inside function right here and how this is inverse tangent. And we know that for inverse tangent lies in either quadrant 1 or in quadrant 4. Tangent is negative in quadrant 2 and in quadrant 4. So this tells me that my triangle should be in quadrant 4. For inverse tangent, we know that it's opposite over adjacent. So we have our opposite, our adjacent. So -24 is going to be our negative value. This is another Python triple that hopefully you know, 7, 24, 25. And then finally, to find the sine of this lovely triangle here, sine is opposite over hypotenuse. So we have -24 over 25 as our answer. All right, so sometimes though, looking at 14 here, sometimes we need to find an algebraic expression. So we don't have numbers anymore. Oh no. Now what we're going to do is always put this in quadrant 1 and hope for the best, honestly. We want to find an algebraic expression for cosine of inverse tangent of x. Inverse cotangent is x over y. So adjacent over opposite. What I'm going to do here is rewrite x so that it looks like a fraction, so that I have x over 1. That way I know what my x value is, which is x, and I know what my y value is, which is 1. And then I could figure out what my hypotenuse is. My hypotenuse is going to be, using Pythag, x squared plus 1. And then to find cosine of this triangle, I'm going to have adjacent, which is x, over hypotenuse, which is x squared plus 1, the square root of x squared plus 1. So this right here represents cosine of inverse tangent of x. All right, likewise for number 15 here, we want to find algebraic expression for this lovely thing. So what I'm going to do here is think about, okay, I have 2x. I'm going to put this over 1, just so that whenever I do opposite over hypotenuse, I know that 2x is my opposite, and then I know that my hypotenuse is 1. I need to figure out what my adjacent is. So using my good old Pythag, I'm going to have 2x squared plus, let me not use x, I'm going to use question mark square is equal to 1 square. Question mark square is equal to 1 minus 4x squared, which means that question mark is the square root of 1 minus 4x squared. Now, to find cosine of theta here, remember that cosine of theta is adjacent over hypotenuse. So this right here is just the square root of 1 minus 4x squared over 1. All right, looking at, let's say, 17 now, we have a fraction, so that's good because I know what my, let's see, this is cosine. So I know what my hypotenuse is, and then I know what my adjacent is. So my hypotenuse is x, my adjacent is 3. I need to figure out what my y value is. So once again, using Pythag, I have 3 squared plus question mark square is equal to x squared minus 9. So that means that my y value is the square root of x squared minus 9. To find tangent of theta, remember that is going to be opposite over adjacent. So my algebraic expression is the square root of x squared minus 9 over 3. All right, sometimes we might have to solve an equation with inverse trig. So we have inverse cosine of x is equal to inverse sine of 2x. And I want an exact answer. Okay, so if I were to think about this logically, we'll see that inverse cosine needs to be in either quadrant 1 or quadrant 2. Inverse sine needs to be in either quadrant 1 or quadrant 4. So this tells me that my answer needs to be in quadrant 1 somewhere. Where? I don't know, but it needs to be in quadrant 1. So here's what's going to happen. What I'm going to do is solve for either the left side or the right side so that we could get the argument out. In this case, I'm going to take the cosine of both sides just so that I have this right here. So I have x is equal to cosine of inverse sine of 2x. Now, plot twist, cosine of inverse sine of 2x. We already did that on number 15 here. That was the square root of 1 minus 4x squared. So what we are going to do here is set that equal to x. We're going to square both sides. And then I'm going to add. And then I'm going to divide. And then once you do that, you'll get plus or minus the square root of 1/5. Now, remember how I told you earlier at the beginning of problem 19 is that our intersection should be in quadrant 1 right here, because that's where inverse cosine and inverse sine are. So what I'm going to do here is evaluate the square root of 1/5 in my calculator for cosine and sine, and they should match up. If they don't match up, then we know that extraneous. So let's look at positive root 1/5. So I have inverse cosine of 1 over root 5. That gives us that lovely thing. And then if I do inverse sine of 2 over root 5, that also gives us the same thing. So we know that works. Now, if I were to do my negative counterpart, I get that. I also get that. So notice how if I have a negative 1 over root 5, our two expressions right here are not the same. So we know that negative root 1/5 is extraneous. So my only answer here is the square root of 1/5. All right, so looking at number 20, we're going to do the same thing. Lucky for us, though, secant is similar to cosine. So we know that our intersection is in quadrants 1 and 2. So theoretically, we might have two answers, and that's okay. All right, so what I'm going to do here is go ahead and take the cosine of both sides so that I have x is equal to cosine of inverse secant of x. I'm going to rewrite that fraction to be x over 1 so that I know that this is my hypotenuse. And then since this is cosine, cosine is adjacent, this is going to be adjacent. Making my little triangle right here, I'm going to have 1x. And then for cosine, I don't really need my height here because remember that with cosine is adjacent over hypotenuse. So in this case, we have this right here being adjacent, which is 1. Hypotenuse is x. I still have an x on the left, so then I get x squared is equal to 1. X is equal to plus or minus 1. What we are going to do here is go ahead and verify that works. So what I'm going to do here is go ahead and go to my handy dandy calculator and say inverse cosine of -1 and inverse secant of -1. Notice how both of them are pi, so that works. So that's in quadrant 2. And then if I did positive 1, that's 0. And this is 0. That's in quadrant 1, my quadrantal angle. So we know that -1 and positive 1 both work here. All right, so for number 21, we have inverse sine of root 3x and inverse cosine of x over 2. This one's going to be very similar to 19, where our solution needs to be in quadrant 1. So what we are going to do here is, let's say, take the sine of both sides so that I get this right here. Make your little triangle for cosine. So cosine x2. And then using Pythag, we should get 4 minus x squared here. And then for sine, sine is opposite over hypotenuse. So we will get this lovely thing right here. I'm going to square both sides, so that's going to give me 3x squared is equal to 4 minus x squared over 4. I'm going to solve this, so then I'm going to get 12x squared is equal to 4 minus x squared. Then I get 13x squared is equal to 4. X squared is equal to 4 over 13. So that means that x is equal to plus or minus 2 root 13. And what I'm going to do with plus or minus 2 root 13 is put that into my handy dandy calculator and see whether they both work. And if you were to do this, you'll realize that only one of them works, aka the positive part. So our only answer here would be 2 over root 13. All right, continue along. We will be doing trig identities in the next lesson.